So in this video, we're going to do section 3.5, which is rational functions. So a rational function has a function on top and a function on the bottom. So that means rational is a fraction. So remember, with fractions, you have to make sure that the denominator is never going to be 0. So now we get to do two more parent functions. I hate you can't see me dance in this video, but the first one is going to be the reciprocal function. Reciprocal function, basically, remember, reciprocals are you just flip them. So if I had x over 1, the reciprocal is 1 over x. So that's a reciprocal function. We're just going to notice a couple of things. First thing is that the x is on the bottom. Remember, we said that x cannot be 0. So since x cannot be 0, you will never have a point on this line. So this line is called an asymptote. So x can never be 0. So we have what's called an asymptote. Asymptote. So there's an asymptote. So your graph is never going to cross that line. We actually have a horizontal asymptote on this one as well, because notice that the top is 1. So when your top is 1, 1 divided by anything can never be 0. It's like you always have one slice of pizza, no matter how many slices you divide your pizza into, whether it's 2 slices or 8 slices or 200 slices, you always get one piece. So that means that your y can never be 0. So we're going to draw it. Now we're going to draw a horizontal asymptote. So notice that divides your graph into 4 pieces. So since this is going to be a function, you either going to have something up here or something down there. You can't have it in both, otherwise it won't pass the vertical line test. So let's go ahead and write the equation of these asymptotes. So the vertical asymptote, your vertical is always going to be an x equals. It's an equation of a line. So it's x equals 0. When x is 0, that's just going to be your y-axis. The horizontal asymptote is going to be y equals 0. So that's going to be your x-axis. All right. So now we're just going to plug in some points and see what we get, okay? So if I have this -2, if I put that on the bottom, that's going to be 1 over -2. Another way you could think of it is the reciprocal. You're just going to flip. So the point is -2 and -2 and -1/2. If I put -1 in there, if I flip -1 over 1 flipped is still -1. So there's another point. If you want to do one more, we could. That -1/2, if I just flip that, that's just going to be -2. That's the reciprocal. So at -1/2, I'm going to be at -2. Notice at 0, I won't have any dots. No dots, because I'm 1 over 0, we can't graph that. It's undefined. Now let's look at this guy. 1/2, let's flip that. So 1/2, the reciprocal of 1/2 is 2. So at 1/2, I'm going to be up at 2. At 1, if I flip 1, I still get 1. And at 2, I'm going to flip that. Reciprocal of that is 1/2. This is nothing like anything we've seen before. Asymptotes are things that our graph is going to get really close to it, but it's never going to touch it. So that's what we're going to do with these points. Get them really close to it, but never touch it. Here we get really close to it, never touch it. Really close to it. Whoops, I touched it. Really close to it and never touch it. So that is my parent function for the reciprocal. The domain, notice the domain, x can be anything, so anything except where my asymptote is. So anything, my domain is going to be anything except, anything but 0. And remember, the way you write anything but something is you do these little infinities. Whoops, let me go back. I like to put a U in there. So this is anything but, and then you put in the 0. So anything but 0. My Y, notice that my Y can be anything but where I have my asymptote. And that asymptote is also at 0. So my range is going to be anything but 0 as well. My intervals of increase, if we look at this graph and sort of follow it from left to right, I'm going to start over here at negative infinity. Notice I just go straight down. So I'm always going down. And then over here, if I start up here, then I'm always going down. So it never increases. So we're going to have none. No intervals of increase. But I do have some intervals of decrease. Notice that on the left-hand side of the y-axis, it's always going down. And then on the right-hand side, it's always going down. So I have two parts of my graph that's always going down. So the first one is from negative infinity to 0. Remember, your intervals of increase, decrease, and constant are always your x values and always parentheses. So interval of decrease is negative infinity to 0 and 0 to infinity. You could connect them with a U. Usually my lab connects them with a comma. And intervals of constant. Now this looks pretty constant, right? At the ends of these guys, they look like they're constant, but they are slowly going closer to the asymptote. So actually we do not have anything that is constant. Where is the last question here is, where is the graph discontinuous? Where do you have to pick up your pencil to go to the next part? And that's where x is equal to 0. So that's my reciprocal function. So notice this one is very similar to my reciprocal function, except I've got a 4 on top. So you can think of that as 4 times my reciprocal function. So if I graph those, I'm going to have essentially the same thing in that my asymptote is going to be at 0, my vertical asymptote. So I'm going to go ahead and draw that, my vertical asymptote. This time I have 4 pieces of pizza, right? 4 pieces. So I can never have 0, no matter how small it is, not even if your roach doesn't even want to eat those 4 pieces because they're so small, you still have some, okay? So again, I've separated our graph into 4 pieces, our graph paper into 4 pieces. I'm going to just do some plugging and chugging. So if I put a negative 2 in there, I'll have 4 over negative 2. That's just going to be negative 2. So at negative 2, it's right there. I have 4 over negative 1, so that's going to be negative 4. So negative 1, negative 4. I'm not actually going to plug all these in because I don't need to, because I know that it's going to be getting really close to my asymptote. Here it's going to get really close to my asymptote. Again, at 0, can't do anything at 0 because 4 over 0 is undefined. And then on the other side, 4 over 1, that's just going to give me 4. So I'll have the 0.14. And then 4 over 2, I'll have the 0.22. So once again, I'm just going to get really close to my asymptote. Over here, really close to my asymptote. My domain, again, is anything but 0 because I have this asymptote right at 0. So anything but 0 is negative infinity to 0, and I'm going to union it with 0 to infinity. My range is the exact same because I can't, it's never going to cross the x-axis. So it's anything but 0. It is never increasing because if you go left to right, see it goes down. And then over here, if you go left to right, it's going down. So never increasing. It's decreasing in two places. This may seem familiar because we just did it on the 1 over x. So it is decreasing from negative infinity to 0. Put your parentheses there because we're talking intervals of increase. Plus, anytime you have an asymptote, you're going to have a parentheses. So that's another good thing to note. Anytime you have an asymptote, you'll have a parentheses. It's also decreasing 0 to infinity. So that's my decreasing. The vertical asymptote, remember vertical is always x equals, a vertical line is x equals, so x equals 0. And my horizontal is always y equals. So it will be y equals 0. I want you to notice the difference between the one that we just graphed and then the parent function. You can't really tell that much of a difference. You're going to stretch it, you know, since it's got a 4 in front, you're going to stretch it. So notice it's a little bit further away from the origin, but honestly, you can't really tell much of a difference because it's so stretched anyway. All right. So now we still have my 1 over x. Okay, so we're still talking about that parent function. So we know sort of what it's going to look like. But remember this part here, it's just like, this would be like if I had negative x minus 3 squared. So instead of using the parent function 1 over x, I'm using the parent function x squared, but the same thing happens, right? This negative 3 just means you're going to move it to the right 3, and this negative in front means I'm going to flip it, right? Flip over the x. So let's first let's draw my asymptotes. That's the easiest way to start. So notice my x cannot be 3. So I'm going to draw my asymptote at 3. Again, I'm essentially taking this asymptote from here at 0 and moving it to the right 3. That's what we said we were going to do. I'm also, notice I have a 1 slice of pizza, so I'm never going to have 0. So I'm going to have my y equals 0. I guess we could go ahead and write our asymptote, the equations of the asymptote. So the one we just did, the horizontal, is y equals 0. But the vertical has changed. That's going to be x equals 3 now instead of x equals 0. Now we can just plug in some points. So if I plug in my 1, so let's say x equals 1. Let me do that in blue. If I do x equals 1, when I plug that one in, I get negative 1 over 1 minus 3. So negative 1 over negative 2. So that's going to be a half. So 1 and a half. 1 and a half. Then let's plug in 2. X equals 2. That'd be negative 1 over 2 minus 3. So that's negative 1 over negative 1. So that's a positive 1. So at 2, 1, there's my graph. So I can connect those and get them really close to my asymptotes. Then I'm going to do the same thing. I did these guys, so that's a half and 1. So I'm not going to worry about plugging in 2 and a half. If I plug in 3, I'm going to get nothing on the bottom. Let's plug in 4. X equals 4, so I'm going to get negative 1 over 4 minus 3. So that's negative 1 over 1. So that's just going to be negative 1. So at 4, I'm going to be negative 1. I'm going to get really close to my asymptote. I honestly only need 1 point on that side to know whether it's going to be above the horizontal asymptote or below the horizontal asymptote. So my domain, this time instead of being anything but 0, it's going to be anything but 3, right? I have from negative infinity to 3. Union with 3 to infinity, so anything but 3. Now my range, notice, is y equals 0. So my range is going to be negative infinity to 0 and 0 to infinity. where is it increasing? So it's going to be increasing from on this portion, right? That's where it's going up, even though it doesn't look like it's going up a whole lot during this part, but it is. So it's increasing from negative infinity all the way up to 3, and then we put a parentheses there because it's going to an asymptote, right? And then where is it increasing? It's also increasing on this side, right? It's going from the bottom up to the top. So it's also going from 3 to infinity. So it's always increasing, so it's never going to be decreasing. So if you notice, we did shift this guy, this one, we shifted it to the right 3, and then notice it's flipped. So instead of being in the bottom portion on the left side of the y, it is now in the top portion. So we flipped it over the y-axis. All right, now let's talk about the reciprocal squared function. So it's the reciprocal, and then I'm going to square it. So it's 1 over x squared. Notice the asymptote, the x cannot be 0. So let's go ahead and draw that. X can't be 0. And also let's go ahead and just write down the vertical asymptote. So the vertical asymptote is x equals 0. And notice that's the y-axis. The horizontal asymptote, again, I've got 1 slice of pizza. So that's never going to be 0. So I'm going to have y equals 0 is my vertical asymptote. So that's my x-axis. Now I can just plug some numbers in. So if I put in x equals negative 2, x equals negative 2. Let's plug that in. I get 1 over negative 2 squared. So that's going to be 1/4. Right? So at negative 2, I'm going to be at positive 1/4. So just barely above the asymptote. If I put in a 1, so x is negative 1, that's going to be 1 over negative 1 squared. So that's just going to be 1. I can go ahead and graph that on that side. Notice when we have 0, it's not going to be anything, right? Because you can't have 1 over 0. Let's go ahead and do positive 1. X equals positive 1. When I plug that in, I get 1 over 1 squared. That's going to be 1. So 1, 1. And x equals 2. When I put 2 down there, 2 squared, 1 over 2 squared, that's going to be 1/4. So at 2, I'm really close to the asymptote. And again, I'm going to draw it and get really close to the asymptote. So I call this guy the rocket. The rocket. Because it sort of looks like a rocket blasting off, right? Now notice that my domain is going to be very similar to the other, my other domains. Notice that my x can never be 0. So my domain is going to be anything but 0. Now my y, my range, notice that my range, I have nothing down in the bottom. So I don't need to start my graph until we get to 0. And I don't actually need 0 because I can never be 0. So it's 0 to infinity. But the 0 is going to have a parentheses. Usually on all these others, we've had brackets because I needed that bottom so that I didn't cut off part of my graph. But if I cut it at 0 and I don't have 0 on my graph paper, that's okay because those lines never actually hit the asymptote. Interval of increase, notice on the left-hand side it's going up. So that's going to be from negative infinity all the way up to 0. Again, I'm going to have a parentheses there because I have an asymptote. It can never be that. Also, intervals, we never have brackets on intervals of increase or decrease. It is decreasing on the right-hand side. So that's going to be from 0 to infinity. Okay, and intervals of constant. Now, I know that it looks like the end of that graph is constant, and the beginning of that graph is constant. But it is slowly going towards the asymptote, so it never actually is the same number twice. So I'm never going to have an interval of constant. Again, it's discontinuous at x equals 0 because when I'm drawing it, I'm going to go up and then I have to pick up my pencil and start again at 0. So let's graph one more of these. Notice that I have a squared on the bottom. So when you have a squared on the bottom, you know that it's going to be a rocket. This rocket is shifted 2 units to the right, and it's shifted 4 units down. So that's super important when it comes to our asymptotes, right? So instead of drawing my asymptote at 0, which is normal, right? It's shifting it 2 units to the right. So I'm going to take that and just move it over here. Notice that's where I would get 0 in the denominator. And then also I have my asymptote that is normally at 0, but I'm going to shift it 4 units down. So let's take it to -4. And we could go ahead and write our equations of our asymptotes now while we're talking about them. So the vertical asymptote is x equals 2. The horizontal is y equals -5, and we don't really need to write the vertical asymptote twice. Okay, so let's go ahead and plug in some points. We really know what it's going to look like, right? We know that it's going to be like this, okay, because it's a positive. So I'm not going to have any flipping, okay? The 2's going to stretch it, but it's really hard to see. But let's go ahead and plug in just a couple of points. So let's plug in x equals 0. So I'm going to have 2 over 0 minus 2 squared minus 4. So that's 2 over -2 squared minus 4. 2 over 4 minus 4. So that's a half minus 4. So if I had 4 pizzas and I eat a half, that's going to give me, what, 3.5 left? So I'm going to have -3.5. So at 0, it's -3.5. So it's going to be about right here. I could plug in other points, but I really don't need to because I know from that point it's going to go close to the asymptote and it's going to go close to this asymptote. So now let's plug in a point on the right-hand side. Any one of these would work. So any one, 3 and beyond. So let's go ahead and plug in my 3. X equals 3. Plug it underneath. 2 over 3 minus 2 squared minus 4 gives me 2 over 1 squared minus 4. So 2 minus 4 is -2. So at 3, we're going to be at -2. So once again, I'm just going to get close to my asymptotes. So it's exactly like what we thought. It's a rocket that shifted 2 units to the right and 4 units down. The domain, again, is look where your asymptote is. Your asymptote on the x is at 2. So my domain is going to be anything except 2. So that's the way we write that in Math Geek form. My range, notice I don't need anything down here. So it's going to be from -4 up. So -4 to infinity. My -4 is an asymptote. So it's going to be, we're going to have a parentheses there. I'm going to go ahead and put it in red because that's what a lot of folks miss. All right, and then where is increasing on the left-hand side, right? On that side, it's going up. So from -infinity all the way to 2. Remember, we are talking our x-axis, our x values. So -infinity to 2 is increasing. And then it's decreasing from 2 to infinity. Notice it's coming down. Okay, so what we have done so far is we've taken our 2 parent functions, so that's 1 over x and 1 over x squared. And we have moved them up, down, right, and left, and flipped them and stretched them, okay? But my equations make it a little more involved than just this. I may have x's on top and x's on the bottom. So we need to investigate this a little bit more. All right, so let's talk about all asymptotes. So my asymptotes will always be where the denominator is 0. Okay, so if I happen to have x, something like this, x squared minus 25 on the bottom, I'm going to have, see I have x squared, so that means I have 2 solutions. Therefore, my solutions, I would have 2 vertical asymptotes. So we could have two vertical asymptotes. My horizontal asymptote, notice so far it's always been at y equals 0 unless we had shifted that graph down. But when we have x's on top and x's on the bottom, my horizontal asymptote is going to change. So first thing to notice is where is the largest exponent. So in this one, the largest exponent is on the top. So if the largest one is on the top, you're not going to have any horizontal asymptotes. That's why in all our other parent functions, you know, we had x squared, we had square root of x, we had x to the third, we had, we've done a whole lot. We've had absolute values, we've had all kinds of stuff. Notice that on the bottom was always 1. We didn't have anything down there, so we've never really talked about horizontal asymptotes because we didn't have x's on the bottom. Now, in case number 2, notice that your x squared is on the bottom. The big one is on the bottom. When the big one's on the bottom, your horizontal asymptote will be y equals 0. Okay, and then finally, what happens when they're the same? See, notice we've got x squared on the top and on the bottom. Then you just look at the leading coefficient. So this one's going to be 3/2. Now, not all of them are 3/2. It's always going to be the leading coefficient on top and the leading coefficient on the bottom. Now, in my lab, they're going to talk about oblique asymptotes. Now, oblique asymptotes mean asymptotes that are not horizontal or vertical. So they're going to be lines. Well, the good news is in Math 110, we're never going to have an oblique asymptote. So in my lab, they may ask for the oblique asymptote, and that would only be when it's matching. You know, my lab likes to do that. It likes to give you a bunch of equations and give you a bunch of graphs over here, and then you match the graph to the equation, or the equation to the graph. So if they have an oblique one, there will only be one oblique. So you can match all of them, and the one that's left would be the oblique asymptote. But we're not going to cover oblique asymptotes in this class. So here's just some things to notice. In rational functions, you could have more than one vertical asymptote. Okay, so you could have 2 of those guys. We got 1 here. We could have 2 of them. Okay, a graph can never intersect a vertical asymptote. So here's Gandalf right here. Thou shalt not pass. And there is at most one other asymptote. In other words, you can have a bunch of the vertical ones, but you can only have one horizontal, okay, or one oblique, but we're not going to talk about obliques. All right, so now let's graph something a little bit different. Okay, first we're going to start with finding just the asymptotes. That's honestly the most important part. It's going to divide your graph into pieces, your graph paper into pieces, and you will have one graph in each of those pieces. So let's talk about the vertical. Again, your vertical is just where the bottom, that's where your bottom is equal to 0, right? So we're just going to set it equal to 0. X squared minus x minus 6 equals 0. Notice we have a squared, so we're going to get two answers. So if I factored that, I'm going to have a 2 and a 3. And let's see, the negative goes with the 3. So I have x equals negative 2, and I have x equals 3. So I have two vertical asymptotes. One thing you cannot do, I'm going to write it this way to show you what can't be done. You cannot write it like that because it's not 2 points. That is 2 points. We need 2 lines, so you actually have to write it as 2 equations. Okay? Now my horizontal asymptote, remember, you look at the degrees. So I'm going to find the biggest. The biggest is on the bottom. So think about this. When the biggest was on the bottom, 1 over x squared. Remember, we had y equals 0. Now let's come to this one. The vertical asymptotes. Once again, we're going to look at the bottom, x plus 1. So set x plus 1 equal to 0. So I get x is negative 1. It is an equation of a line, so we'll have a vertical asymptote at negative 1. My horizontal, I'm going to look at the degrees again. Notice that they're the same. So I have 4x over x, so I will just grab the leading coefficient, which would be 4 over 1, which is just 4. So my horizontal asymptote is y equals 4. And now my vertical asymptote. For C, once again, we just look at the bottom. We set that bottom equal to 0. That was supposed to be a negative. Negative 1 equals 0. So x is positive 1. Once again, you write it as an equation. And my horizontal asymptotes, the biggest one is on the top. Remember, we look at the degree. So the biggest is on the top, so I know there are none. So to graph these rational equations, you're going to find the vertical and horizontal asymptotes. You're also going to find the x-intercepts and the y-intercepts. Now let's talk about x-intercepts. So here's my x. When I have the x-intercepts, notice that's where my y is 0. So you are going to set the numerator equal to 0. Let's talk about why just the numerator. Because in all our other ones, like when we had something like x squared minus 25 equals 0, we set the whole thing equal to 0. Well, now let's put it over something else, x plus 1. So now we've turned it into a rational equation. Now, the way that you would solve that one is you would just cross multiply, right? So if I cross multiply, do you see that I'm getting my denominator times 0 and then my numerator times 1? So I would wind up with x squared minus 25 equals 0 anyway. So it's just easier to remember to set the numerator equal to 0. But if you set the whole thing equal to 0, you're going to wind up with the numerator equal to 0 anyway. So now let's talk about the y-intercepts. So for y-intercepts, if you have it cross on the y-axis, notice that my x is always going to be 0, so we just plug in 0 for x. Okay, so here's our little summary. To get the vertical asymptotes, you're going to set the bottom equal to 0 and solve it. To get the horizontal, you're going to look at the degrees of each one. To do the x-intercept, you're going to set the top equal to 0. And to do the y-intercept, you're just going to plug in 0 for x. So here are my steps. Notice that in the summary, we set the top equal to 0 or the bottom equal to 0 and solve it. So I go ahead and factor the top and the bottom. That's usually my first step because if you have a squared there, that's what you're going to have to do anyway. So I factor it if I can. Then I'm going to find and graph the vertical asymptote by setting the bottom equal to 0, and then I'll graph the horizontal. So I graph my asymptotes first. Then I find my x-intercept by setting the top equal to 0. Then I find my y-intercept by plugging in 0. And then I just plot a bunch of points to see if what happens on the top or the bottom of the horizontal asymptote. And then number 7, I don't want you to do this, but just in case you cannot figure it out by plugging in points, you will plug it into your calculator. Plug it in your calculator to, let's just say it, to cheat. I think it's cheating, but the other math teachers do not. So that's why you get to use your calculator. All right, so let's work a few. All right, so this first one, I'm going to factor the top and the bottom. The top, I can't do anything to. I'm just going to leave it. But the bottom, I think the bottom, we factored this one before. 3 and 2. So this one's going to be negative. That one's going to be positive. All right, so I factored it. My vertical asymptotes, remember vertical asymptotes, we're going to look at the bottom. All right, so we're going to set the bottom equal to 0. X plus 2, and I'm just setting it equal to 0 for your notes. You don't actually have to show me that because we know just by looking that this is x equals 2 for this one and x equals 3 for this one. So that is my asymptotes. Again, you must write it as 2 equations. Let's go ahead and graph those. So I've got 2 here. Got one at -2, and I've got one at +3. My horizontal asymptotes, remember, I'm going to look at the degrees. So notice the big one is on the bottom, so that tells you y equals 0. So let's go ahead and put that horizontal asymptote in there. And now I'm just going, I would just plug in some points, but MyLab always wants x-intercepts and y-intercepts. So my x-intercept, remember your x-intercept is here, it's like that. So that's where my y is equal to 0. So I let my top equal 0. So x minus 2 equals 0. So my x is going to be 2. Now, notice that is a problem. It's a problem because it's right on top of the horizontal. And Miss Kitts, did you not tell me that we can't ever touch the asymptotes? Okay, I lied a little bit. All right, so you can never touch the vertical ones. That's why Gandalf said, "Thou shalt not pass." Thou shalt not pass. But the horizontal, honestly, are just suggestions. Occasionally, you will cross them. And where you cross them is usually right here in the middle, okay? I will go ahead and make a promise to you guys. On your test, it will never cross on the outsides, okay? So you're either going to have graphs that do this or do this. Or this, or this. I'm never going to have them cross on the outsides. Okay, that's my promise to you. On the inside, all bets are off. You can cross in the inside. Okay, so the y-intercepts, let's figure out the y. Remember, y-intercepts will be up here, right? And notice that's where your x equals 0. So let's plug in 0. Just in your notes, I'm going to actually plug in, but in the for reals, you can just cover up all your x's, and this is all that's going to be left. -2 over -6 is going to give you 1/3. So your y is at 1/3. Let's see, y is 1/3. So about right there. All right, so that right now that's just confusing. So I'm going to go ahead and plug in some points. I'm going to figure out what this is over here. So let's plug in anything from -3 to -infinity. I'm just going to put in a -3. So if I put a -3, I'll have -3 over -2, and then -3 squared minus a -3 over minus -6. Goodness gracious. Okay. So 9 plus 3 minus 6 negative 5 over, what's that, 12 minus 6, negative 5/6. Okay, so at negative 3, did I say negative 3, sorry. I'm just a little bit down here. So I don't have to plug in any more points. I go close to my asymptote and close to my asymptote, and I'm done. Okay? So now I'm going to find a point over on this side. We'll worry about the middle in a minute. All right. So you can plug in any of those points. I'm going to go ahead and plug in maybe 4 or 5, either one of those. Let's see. I'll plug in 5. So if I plug in 5 here, I'm going to get 5 minus 2 and 5 squared minus 5 minus 6. Holy moly. 3 over 25 minus 11. 3 over 14. Okay, so that's going to be really close, but notice it's a positive. So I get really close, but I know it's on the top. That's what I care about, is that it's on the top. All right. Now, in the olden days, when you didn't have a graphics calculator, you would go in here and start plugging in these points. I would plug in negative 1 and get a point. And I would find out, is it going to be down here somewhere on the bottom, or is it going to be up here? And then I would come in and I would plug in a point here. In between 2 and 3, I'd have to plug in a decimal to figure out if it is it going to go back up like this, or is it going to go down like that? I would have to plug in a decimal to figure that out. I could easily plug in negative 1, and if I do, I'm going to get a positive. But this is where you get to cheat. You get to cheat. You get to put in, I think I already had it in. There it is. Went in, plug it in. I hit graph. And notice that on the left side, I got that right. On the right side, I got that right. In the middle, it's going up on the left and coming down on the right. Notice it looks like there is a line right at 3. You see that on the calculator? It looks like there's a line right at 3. But that's just because your calculator graphs this, and then when it graphs this part, it then connects it. So it's going to connect it up here to start graphing this, but that line is not really there. Okay, so on that one, you got to cheat. All right, number 6, let's do number 6. So number 6, I could factor the top. Notice that I could take a 2 out of that, but there is no squared in it, so I'm actually not going to do it because it's not needed. Because I only factor when I have to set the factors equal to 0. So I really don't need to factor that one. My vertical asymptote, again, I look at the bottom. Where is it equal to 0? So that's going to be negative 1. So let's go ahead and draw that in. Draw that at negative 1. And then my horizontal, remember we look at the degrees. So look at the degrees. Notice my degrees are the same, 4x over x. So I'm going to have y equals 4. So I'm going to draw my asymptote at 4, my horizontal. All right, let's go ahead and find my x-intercepts. My x-intercept, remember that's when you set the whole thing equal to 0, but the bottom just cancels out. So we're just going to say where the top is equal to 0. So I'll work that one out. 4x minus 2 equals 0. So 4x is 2. So when I divide by 4, I get x is 2/4 or half. So my x-intercept is at a half. Right there. They want the y-intercept. So my y-intercept, remember, I just plug in 0. So I'm going to have 4 times 0 minus 2. And again, in your notes, I'm plugging it in. But you really don't have to plug it in. You can just cover up the x value. See if I cover that up right there. All I've got left is negative 2 over 1. So that's going to be a negative 2. I'm just going to connect those and make it get close to the asymptote. All right. So to get on the other side, all I need to do is plug in one of these values. One is fine. So let's say I'll do -3. Doesn't really matter which one you do. 4 times -3 minus 2 over -3 plus 1. Let's see, that's going to give me, whoops, -14 on top, -2 on the bottom. So that's just a 7. So at -3, I'm at 7. So that's that point right there. So I'm going to go close to that asymptote and close to that asymptote. All right. So this one, number 7, is a little bit odd. It makes me not want to do it with you because I'm really never going to give you one like that. But let's talk about it a little bit. The bottom I could factor. That's going to be x plus 3 and x plus 3. So I have one vertical asymptote, right? My vertical asymptote is where x plus 3 equals 0. So that's going to be x equals -3. So I would have a vertical asymptote right here. My horizontal, notice that I just look at my degrees. My degrees they're the same, so I just do 2 over 1. So y is equal to 2. So let's make my horizontal asymptote. It looks innocent enough right now. Let's do my x-intercepts. Now my x-intercepts, remember that is where the top is going to be equal to 0. So if I do 2x squared plus 3x minus 4 equals 0, if I try and factor that, it will not factor. Doesn't factor. So I have to use my quadratic formula. So I'm going to just write quadratic formula. And when you plug it in, you're going to get about, I'll make it wiggle, about 0.85 and about negative 2.35. So let me put those in there. So about almost 1 and then a little less than 2. Well, that's interesting. This is where you know it's going to be weird. So let's go ahead and put that in there. 0.85, 0, and negative 2.35 and 0. My y-intercepts, remember we just plug in 0. So when you plug in 0, notice that means all of this, that's gone, that's gone, that's gone, and that's gone. So everything is gone except my -4/9. So that's going to be my intercept. So -4/9. So that's about almost a half, right? So that's about right here. Well, that means this guy makes no sense. This guy on this side makes no sense. If I did not have that number, that dot, then it would do like this, right? But it's not doing that. Something is going on weird with that one. But we still have to do something here. It's either going to be above or below my asymptote. So I'm just going to pick up one of these points. -4 to -10 somewhere. Let's pick -4. Let's see, or -5. Let's pick -5. If I plug -5 in there, I'm just going to cheat a little bit. And I already have done that. So I got 7 3/4. 7 3/4 when I stuck it in. 7.75. So at -5, it's going to be 7, almost 8, somewhere around here. So I know it's on top. So I know this is going up, and I know it's coming down like that. Okay, but this is the weird guy. This one here. And this is where it would have taken 30 minutes or more to figure out what's going on. Thank your other math teachers for letting you do this. So I'm going to clear this out. Let's put in the other one. I'm going to use my alpha y equals to get a fraction. If you don't have that function, remember you need to put a parentheses first. And then 2x squared plus 3x minus 4. If you don't have the alpha y equals function, put your parentheses here, put you a division sign, and start another parentheses. Okay, and then write x squared plus 6x plus 9, and then close your parentheses if you don't have this function. Now we're going to graph it. Well, isn't that weird? So it's going to connect. It's going to connect all those dots, but then it's going to go straight up. So it from here, from this point, it goes straight up. Then it's going to come down here and then come back up. So just so you know, I'm never going to give you one like that on a test. Okay? On your test, you might have something a little weird in the middle, but nothing that weird. Okay. This is just a reminder. If n is even, n is your degree. So if you have x 1 over x squared, it's a rocket. If you don't, it's not a rocket. That was your little reminder. All right. So this one, example number 9. And this is the last one in this section. So once again, we're going to factor the top and the bottom. So when I factor, I'm going to get my x and my 2 and my 3. And this one's negative, this one's positive. One thing I want you to notice that's different than all the other times we factored. These guys will cancel each other out. Do you see that they cancel? So when you have factors that are the same on the top and the bottom, they cancel, which means there is a value that I could plug in right here. Whoops, sorry. I could plug that value right in for my x. That's going to give me a 0 on the top and a 0 on the bottom. Okay, when you have that, you have a hole in your graph. So how do you graph something with a hole in the graph? Well, first thing we're going to do is we're going to graph what's left after I cancel it. Okay, so the equation that's left, I'll do y equals, well, it's really f of x equals, but I like to think of it as y equals x plus 2. So x plus 2, if I graphed that, remember this is my x-intercept, this is my slope. We haven't graphed lines really. So my slope is 1 over 1, and my y-intercept is 2. So I'll start it at 2. And then I go up 1 to the right 1, up 1 to the right 1. And I do a bunch because I am linearly challenged. In other words, I can't draw a straight line. Okay, but that's if the equation was just y equals x plus 2. But that's not what we started with, right? We started with a fraction. Notice that this one, I meant to do that in green, this one, x cannot be 3, right? So I would normally draw an asymptote right here. Now, but we're not going to really draw an asymptote. But what I notice is that it goes through one of those points that I drew. So that means that at that asymptote, I can't have a point there. So I'm going to erase my asymptote, and I'm also going to erase that point and put a big old hole in my graph. And then I'm going to connect the rest. See, I already told you I was linearly challenged. I'm going to connect that one, and I'm going to connect it to that way. Okay, so I have a line with a hole in it. And the question is, where's that hole? Well, I know that the hole was where x is 3, right? Because x can't be 3. And then to figure out the y value, either you could look at the graph if you've already graphed it, or you could plug it in. So what x gives 0 on the bottom? 3. Okay, now I'm going to plug it in. Y equals x plus 2. So 3 plus 2 is going to be 5. So that's where my hole is. And sure enough, that's where the hole is. So anytime in this class, now you can have holes in any graph, right? But in this class, if I give you a hole on your test, it's going to be a straight line with a hole in it, okay? Which means if you plugged your equation, this guy, into your graph, into your fraction your graphing calculator, you're just going to get a straight line. You won't see the hole because it doesn't have the capability of making this big old hole in it. Okay? All right, so make sure that you have watched this video. Of course, if you get to this point, you've watched it. Make sure you've attempted all your homework and come in with problems, okay? Anything that you got stuck with. I believe this is due before we meet again. So email me if you get stuck on your homework, okay?